Guess I will stand here and play the shoot. All right, folks. Thanks for coming to the Texas Systems seminar. So this is the very first, talk in the series. And the Texas Systems seminar is meant to bring people doing sort of cool tech stuff in Austin to sort of like the CS department and expose sort of like our students and faculty these like cool ideas. So today we have David from Quali talking to us about like orchestration. Um, David has been doing tech roles for like a long time now. He's worked at like Intel, Data, and CSense. He's been at Quali, I think, a little bit over 4 years now, I think. And Quali, if you've not heard of it, is a startup in like Austin, which is doing automatic governance of like digital infrastructure. So think about things like where you're spinning up AWS instances, forget about it, and it just keeps running up your bill. But think about this at scale, like with like 1,000 engineers all across your company, provisioning everything all over the place. So Quali helps you manage all of that. We ran into like the founder of Quali, and he was telling me about his company, like super cool, and I wanted you guys to all hear about it. So with that, I'll hand it over to David.
Okay, awesome. Thank you. As I promised, it's going to be low key. Okay, so no, I'm not going to give you a rank later or a test. It's just for fun and for you to ask questions. It should be also interactive. So whatever questions you have, and we can even go ahead and kind of sidetrack and talk about other stuff, and that's fine. My personal passion, again, was around getting my software out there to the world. I did it for the past 20 years or so, and it's called DevOps. It's kind of the operation between the dev, solving complex problems in organization. And eventually, I found myself kind of joining Quali because this is the mission. We want to help solving that and commoditize it to the world. And today, focus will be around how can we not agentic mess in the world. So infrastructure matters in the world of AI even more. And I'm going to start maybe with this statement, right? So why this matters, actually Gartner, again, claims that by next year, 80% of all cloud operation will be managed and performed by autonomous agents, right? This is okay. I believe that I don't like talking to humans. So having an agent doing all the stuff for me. So again, what can go wrong, right? And to be honest, our mission right now is to prepare for such world, okay? To create that operating system for what will happen when autonomous agents will just run whatever they want. And let me start with a question. Did any one of you developed in the cloud before, like spin up an instance or something? Oh, fantastic. Let's maybe ask one more. In what, let's say, organization or process did you do that? It was like for yourself? Is it part of job? What did you do?
Like you're doing research, like you want some like machines that has the hardware you need for
Okay.
your certain work.
And how did that went for you to get access to it? Was it fine, frictionless, great?
Like if you only need one machine, it's pretty easy to do. But if you need like a lot of machines, then you need to like set things up and have them connected correctly and kind of configurations need to handle.
And you manage that configuration like easy peasy, or you kind of?
Sometimes there's some problems and you need to do it again and again, and you want that to kind of.
Did you have to ask help for someone, from someone?
Sometimes.
Okay.
Yeah.
Yeah, that totally makes sense. That skill that is not of abundant, right? Of how to configure properly a network, compute, storage, using Terraform, some automation, right? This is it takes some time to learn. And I want you to look at this at least graph, because this is where we started a few years ago. We started with a place where there is growing demand and not a lot of supply. So people less and less know on how. So have you ever looked at assembly? Yeah. Okay, that's amazing. I didn't expect that. So I was kind of from that region of coding in assembly, sadly, and now no one knows about it. It's like even JavaScript kind of went away because it's become the assembly of the internet. So same goes with infrastructure and practices and how do you, like networking. Do you know networking really, right? You have to learn it here. But so there is a lot of, let's say, skills that are shrinking. And guess what? More and more hands coming to the keyboards requires more and more access to those hardware infrastructure and applications. And fun fact, right now we know that if a developer in an enterprise like access, it takes him 6 weeks. It's ridiculous. And I can't even say it. But we also know that the absurd thing is we have a lot of waste out there. So whenever you have like GPUs spinning up and ready, sometimes they're underutilized, like 70% of them. And when you're done with it, they're just there for most of their, let's say, purpose. And it's going to get worse. It's going to get worse because we're switching from 45 million developers around that time to what anticipated to become like an explosion of agents. And that comes, of course, with lack of control mainly. But wait a minute, let me just move it like that. But not just that. Today, focus will be around the control aspect, okay? But we have many, many problems coming up to our, let's say, era with agentic behavior, and the demand is growing, so how can we gonna manage that? And the easy way to understand it is, or what is complete loss of control is by looking at a simple example. So we're gonna do a simple example. And when I talk to Grok sometimes or Gemini about like, what does PhD student like to look at? Sometimes it's show them the equation, and sometimes it's show them something simple. I don't know. So we'll see. And we're going to do A/B test on what Grok offered. So I'm sure you heard about NextFlick. This is customers of ours. And I don't know who watched Stranger Things. Is that something that you know? Okay, thank God. I was like, if no one knows or anything, I'm gonna move to something else like Pokemon or something. I don't know. Anyways, so that they're well known as the pioneers of microservices and chaos engineering, and basically they mastered everything from services sprawl. I don't know if you heard about it, but they have a very, very strong platform engineering culture. So they know everything about building themselves. They're kind of excellent in that. Now, imagine 50 LLM agents that holding the keys to the same AWS account. Now, I'm sure that you sometimes think that all the agents are aware of each other, but obviously from a simple kind of scenario, this is not the case. So what is the very first thing that can break? So obviously, when we look at the new problem that they're facing, and we're going to dive into examples in a minute, it's the agent sprawl. Hundreds of autonomous AI agents that are taking the role of DevOps, SRE, FinOps, trying to manage everything themselves. And you get to a point where in the season premiere, you're seeing the buffering. Now, there is a nuance to that because NextFlick has perfected how they're shipping content by distributed systems, network, CDNs, etc. Everything is on the edge, fault tolerance switches immediately. But when it comes to streaming live events, not like Stranger Things, but for example, boxing matches, they actually hold all the information because it's real time. And they are facing scaling issues. So now imagine that you're getting a notification about a latency. And that alert comes from two different systems. They got Datadog, they got other New Relic, whatever, getting notifications. Two teams jump into action. Those teams are actually autonomous agents. And what do they do? So obviously this guy here is based on Gemini 3 anti-gravity. I don't know if you guys used it. Who used anti-gravity already? Oh, come on. Okay, so what did you think about that, by the way? I'm not working for Google.
Asking me.
No.
It was alright.
It was just all right?
Like it's like a little better than Cursor.
To me, it was order of magnitude better, but and this guy actually is on the free version, so it will generate some code, but maybe do some planning before, and then ask you if we can apply the changes. This guy is fully autonomous, but as it happens, the concurrency problem is, simple as that. We learned that from atomic bits in registers and CPUs to just applying Terraform configuration. And the reality is that you will get immediately locked or an end locked. So again, concurrency problem, classical one, and this is what you're deserving at the end. Now, see, okay. I believe that when we look at the generic problems, okay, and trying to generalize where we're heading, there's a lot of papers around that area around now about how to do effective collaboration between agents. It's not a mistake that the protocol of agent to agent is not widely used, like MCP, for example. MCP is like this standard right now. And there is a lot of protocols that are actually close and similar to A2A that is developed by Cisco, that are developed by other companies, and they're now still competing, but they're trying to understand the boundaries on how it will behave and what they can promise in the worst case scenario and how it will be. And when we look at, I don't know if you saw the N here, I like that, but when you have the an autonomous agent that are LLMs, and you look at the definitions, so each agent will probably have access to just its own memory with no knowledge about others, and you have to assume that because it's a worst case scenario. And they will probably have direct access to whatever they need to do, otherwise they won't be effective, right? And the resulting failures of such pattern is three main ones. One is the race condition that we saw. That happens quite often. You have to guard around that. You have to move from, I would call it choreography to some orchestration. And the other one is serious economic issue, which is the token explosion. And when it comes to token explosion, we look at classical problems like click, and basically how every new observation, new decision, new tool result have to reasonable across and broadcast across all the click and all the agents in order to make a good decision. And I would say that if you look at frameworks like LangChain and Crew AI, and we talk about a few maybe, they have a very flat approach of how to debate, which actually yields at very high complexity. And the last thing is there is no guarantee, right? When you go to Grok and you type something, it says, please check, we can make mistake. It's still the case when it's autonomous and you wrote the code even. So no guarantees of failures. So what do? And the interesting fact that I stumbled upon one while researching it, because we definitely want to have a statement in such world, right? On how can we solve that chaos, was the question, how many agents, or I wrote it here, like, if you know that this is how it grows, then what is the N that you need in order to not spend more than, the worst case? Like, how much do you think? How many agents do you think that you should have in your click until it's getting worse than the gain that you will have? Throw a number. I know it's
1,000.
1,000. No. By the way, I like the meme of how do we solve problems? Put agents on it. and then more agents. It's kind of classic. So apparently, from that research, it's around 8, which is kind of insane. So in a mesh like that, and just imagine that now you're using MCP in your IDE. So that's kind of, we don't look at it as agent. You have one real agent. But now when it comes to the picture, a lot of sub-agent that try to manage your context windows. And again, have you used sub-agents? Have you heard about that concept? So just generally speaking, I know that I'm a little bit off topic and I might get late, but you asked me to kind of brain dump stuff. So I'm just saying that we're all experimenting with new versions of whatever the Copilot team is issuing, and Cursor and anti-gravity, and we want multi-agent. This is the target. And how do you coordinate multi-agent on local machine is even a smaller problem than the generalized one, but it's still hard. And the real problem is still hallucination. So when you have a large context that keeps growing and growing, you will get more hallucinating, even if you have a stronger model. Now, in order to solve that, they created a really nice thing called sub-agents that actually goes, do a job, whatever they're issuing and finding out, not part of your main context. Okay, it's in different context window. And once they have the result, they're shrinking it, passing it back to the main context. So you are, let's say, lighter and more coherent. And so 8 agents, and I would not refer to sub-agent in this case, but 8 agents that are trying to coordinate together. So imagine that you need to push code to production. How many agents you really need? So what is an agent, by the way? To me, agent is a persona, it's role. I am the best in Git. I am the best in writing Terraform in a compliant way in enterprise. I'm the best in whatever domain. So just to push code to production, you will need more than 8. Okay, you will need the Git and the GitHub and the cloud and Terraform, and you will need the code review, and you will need a security guy, and you will need. So I won't name them all, but this is fall apart very quickly, and it's backed by, again, researchers that doing that for fun, like yourself. This is where I want to be, but yeah. So anyways, kind of a tough luck. So what should we do? How can we solve this problem? Any thoughts? It's kind of simple. It's not it's not, yeah. All right. How do you do that? They still need to coordinate somehow.
Each of them have bases like they don't like kind of cross coordinate.
So you're saying something like in a form of shared memory, or like how do they communicate without communicate? Because they need to execute a task eventually. Yeah.
Maybe some sort of hierarchical agent structure. I know this problem came with the assumption of flat like network. So if you have a hierarchical structure where there are sort of lead managers that are relaying
That's
communication.
right. And you know what? It's kind of the poor man's way developer of doing that hierarchical. You have your instruction file and your constitution of what you're allowed to do, and you are telling it what to do. You don't want to do it, but you have to, because this is a way to hierarchy. So you're right completely. I actually referred it as the real problem, which is the missing orchestration. And we found a way right now in the industry to, and again, it's not standard yet, but to pass some sort of specification and instruction between teams right now, so they will act the same way. But ideally, you want to solve it like again, like a service, like a system. You don't want people to take care of that and tell the agent what to do. So we know that we don't have shared memory. We know that the sequencing matters, and you have to coordinate that. And you know that you don't clean up after yourself. You just keep retry, and obviously it kind of amplified. So this is one way of moving from choreography to and orchestration. And this is kind of a glimpse of our product. And I'm going to talk a little bit more about that, because this is the talk discussion, not product, but how we took principles and algorithms and models that are kind of solid engineering and made it, possible to solve such challenges in a very elegant and nice way. I would say that now we will drill down to the actors model in a minute, but I want to say that once we introduce the concept that we bring to the world, which is called environment, it's kind of simple, but an environment, which is our Torque environment, actually just put a box on, whatever's going on. It doesn't allow agent to communicate directly to the cloud. This is the first rule, or to your data center, or to do whatever. Sorry for looking at you. You're okay, but it's just make me, So we don't do that anymore. We also would like to define a boundary that is encapsulating the state, encapsulate the policies and life cycle, and essentially we can define this environment as one actor, which is the orchestrator. Now, the workflows basically change a little bit, but you get the idea. You're basically orchestrating. And we're gonna talk a lot about today this guy here. I know it's in the bottom, but when you're working with environment, you will actually get benefits that you usually don't think about, which is lifecycle management. In the real world, you have a lot of tools to solve problems, and those problems usually has a lifespan. So, for example, provisioning. Who used ever Terraform in his life? Wow, amazing. Who used Ansible? Who used Helm? Who used Bash? So you get the idea that for day zero, you would like to use Terraform because it's easy for provisioning and lifecycle management. When you would like to configure something day two, you have scaling concerns, you have patching that you need to do, something on the OS, there you use Ansible. So you get the right tool, but it still needs to be managed throughout its lifecycle. So when you use an environment, you will get that. Obviously, dependency mapping and the inference code is agnostic. You can use whatever you want. And this is the desired approach. Like now, when you go to agent, you don't care if it is going to code in Python or in TypeScript. So the same goes with the concept of managing infrastructure. And obviously, what we talk about today is the blueprint, which is the source of truth, and how we define everything, the topology in a declarative fashion. You also will get policy embedding, guardrails around cost and day to action, which is big. I can do a separate lecture about what day two actually is, but the most, let's say, fundamental problem there, again, is context, same as with agents. If you want to perform something effectively, you have to have the right IDs, the right credentials, the right authentication, right everything, and obviously the knowledge on how to do that. I don't know if you remember, but we saw these guys here, all of these. So all of these guys, we call them grains, and all the grains that you saw basically are actors. We call them agents. Not AI agents. Some of them are AI agents, but AI is like an agent. It's kind of washed already. It's kind of hard. We need a better name. Call it DBS. We have a lot of DBSs, and essentially, because they are falling under the model called actor model, it's very easy to understand what they do. Now, who knows what actor model is? Okay, how do you know about actor model?
It's a model of computation based around passing messages between actors which have mailboxes.
That is correct. But did you have the time to touch it, to play with it?
Oh yeah, I learned Erlang.
Oh, nice.
My PhD is in programming languages.
Oh, nice. So actually, it's not a well-known one. Whoever is, Erlang maybe encounter it, maybe. But yes, Erlang is based on it. And what blew me away about this model, by the way, the computation model, is that I learned about Turing model. It's a theoretical one. I thought there is nothing else. And suddenly around the 70s, someone posted a paper that he has another computation model that is even practical, and it helps you to scale in a distributed system. That was fantastic. So just the application on it is just very interesting. Two of them, main one was that WhatsApp is based on it, and also Halo, whoever plays Xbox. So that is kind of nice. And what's your name?
Right.
Arthur. So what Arthur said is essentially, it's a very simple model. An actor can basically do three things. He can send messages, he can spawn new actors, and he can do some work. And essentially that computation model is close to a lot of, let's say, reductions that you can do to Turing, but essentially it has compute, storage, and network all to himself, and he can just operate. So with that said, whoops, kind of spill the beans there. We got actors, right? Is that all? This is all what we need? What do you think? Okay.
And there's the whole supervisor tree thing, which is, I think, where we're going with this.
Yeah, kinda. So it's not just a supervisor, but we know that orchestrator actors are not enough in the world. Okay, you have different problems that we tend to overlook once we are okay with distributed systems and everything works at scale, but stuff will go wrong. So especially when it comes to stuff that I don't control, AWS. I don't know if you've been around for the EU. What was that? It was the US East 1 that went down. Like half of the internet is on it. Yeah, we suffered. So what happens if that goes wrong? How do you recover? And what happens if you're on a binge doing Friends? Again, I don't know if you saw Friends, but I love Friends. You binged it and you fall asleep. So what are we doing with those streams, right? Those compute that we're actually working to provide. So eventually it becomes a hard problem to go and kind of bookkeeping it after the fact. You have to think about it. And to solve that, there is an easy fix, okay? TTL. You put TTL on boundaries, on actors, it's easy. But is that good enough? I'm asking because the answer is, of course, not. But what else can go wrong? We have long-running transactions. We have actors that can break, which leads me to we need resiliency. So let's go to Saga to the rescue. What time is it? Oh my God. Okay, I'm gonna split it up a little bit. So TTL not enough. We need Saga. So Saga, like actor model, is kind of a pattern slash, it's not computational model, but it guarantees a lot of stuff. I liked computer science. I'm a master, not more. But I like that because you understand a data structure because you know exactly what you're going to get. And same goes with patterns. I can talk to you about the product and how it does. And when I go to talk to sales and partners and investors, I can tell them stuff. But when I go to someone and I say, I'm using this design pattern, you immediately get it. And this is what I liked in computer science. Everything is modeled to solution that we already know. And Saga is one of them, which eventually promise resiliency. It's saying, you know what? Let's break tasks and problems to the smallest as you can. You can use actors to perform those tasks, which is great. But assuming that something will go wrong, we will then basically fall back and kind of take all the transaction back. And that's really important in distributed system, that the sequence matters. And we took that, obviously, implemented that. We're going to see in a second how. But what I like is, and you always try to find a way to get Jensen into the conversation. This is my way of doing it. So obviously, resiliency matters. I don't think that he meant people. I think that he meant software that needs to be like with low expectation. Then you're going to build a lot of resiliency on top of it. By the way, next flick is fantastic and phenomenal with doing that, just that. Most of what you're experiencing is resiliency at its best, not pure algorithms. It's kind of how to overcome them. And let's put it all together, okay? How do we get from the story that I told about many resources in the cloud that has some architecture and resources and agents that need to understand that to something that is controlled, managed, and basically transforming it into an environment? And for that, I would like to introduce our minimal actor concept, which we call a grain. And obviously, it's the smallest computation unit. It's event-driven, isolated state, extendable, customizable. And when you look at it comparing to other, let's call it models and computation models, like, for example, the LangChains and the auto GPTs, I try to create kind of a slide because it's really hard to summarize. It really depends on, right now we're talking about a concept and we're talking about the building blocks, which is theoretical. It's not real, and it's not a system, okay? Systems matter, product matters. So LangChain has a great product if you're building a flow of agent and you want to work with Python, it's phenomenal. But when it comes to solving infrastructure problem in the real world, when it's, I would say, distributed, there's a lot of missing items that you cannot do with LangChain or with temporal or with other frameworks. And it's not a product at the end of the day that solves that problem. So with that in mind, I would like to kind of show you an example on when you take Terraform, the grain concept actually is, okay, on start, you're doing init plan, updating, you're doing apply, destroy. You can have different actions. And this is how we designed our agent to some degree. So it can take the shape and form of whatever IA see out there and just act upon it. From a physical standpoint, we're running as containers in Kubernetes. We have our compute, we have our storage, and we have our permissions, which is very important. Taking the keys from everyone else, we need to manage that ourselves. And this comes in the form of service accounts and others. I'm trying to speed it up a little bit, so I will leave some room for questions. But essentially, when you want to build something meaningful, you will go and use blueprints. Blueprints, as it sounds, it's kind of the template of everything, contains many grains, and it's source controlled, which is fantastic. It's code-based, so agents can do whatever they want with it. We have our own agents that build that and our profession with building blueprint. And I think that this has a good kind of understanding of what you can do with blueprints. So imagine Lego pieces. So right now, when you look at the problem, you usually tend to focus on, okay, what is the next step I need to do? How can you make that reusable, composable, nested in other Lego pieces? Eventually, the world needs bigger Lego pieces, okay? They don't need that assembly. And this is what the product does for you. It curates all the best practices and offers them encapsulated in that form. So looking at kind of I would call it a practical example of how actors in Saga pattern works together. So the environment is kind of the distributed actors across any target. Can be on-premise, cloud, edge, doesn't matter. It has a long-running operation that's split into local steps, which are basically more grains and more actors. Every step eventually has a encompassing transaction using the Saga, so you can always fall back and make sure that you're good. And there are no rollbacks, no global rollbacks. And okay, no zombies. That's important. Now, I wanted to get to these last slides, and then you can kind of have maybe more tangible of how it looks when they say blueprints. So eventually, a simple blueprint might look like that. You got inputs. Those inputs are either user-facing or other grain-facing or other actor-facing. you got your outputs, same goes, you're kind of defining your IO, and then you have like a very thin layer of pointers. I want to go to this agent with this service account with that input, and that's basically it. And when it comes to how do you manage that, then you have basically, again, I wanted to provide some concrete examples, and I thought that that would be maybe interesting in Kubernetes, but when it's one grain, it basically looks like that: pod, service account, etc. If you have the same service accounts and you have many grains, you still want to manage the states of all of them, but you can do that on top of one physical kind of pod with storage. We're doing the split, whatever. I know that you guys are working on storage, so there are a lot of interesting stuff to be discussed, especially when it comes to how do we help agentic workflows with data, and how do we save the data. So kind of maybe follow up. When you have different service accounts for grains, then you kind of have to split that physical runtime, and you can also decide to do that and signaling, obviously oversimplifying everything right now, so it will be kind of digested. I believe that when I think about the world, it helps me translate into operating system, which is, again, processes and threads and containers and sandboxes, etc. So this is how I like to think of the world. And with that said, I know this is kind of hand-waving stuff, but we're seeing excellent results in our customers. So some of them want to optimize their agents' communication, and some of them really just want control on their infrastructure because they have distributed teams that cannot operate at scale right now. We have a lot of customers that just want to make sure that they have like 5 people team on 1,000, and they want that 1,000 to just consume infrastructure. So they're using those constructs of blueprints to do that, again, concurrently at scale. I think that I'm going to stop here now. I had a question that I wrote to myself, which is, in 2 years, you're probably like every engineer, and you will have your own personal 50 agent that you like, right? So, and every company will have millions of environments as well. So the only question that we are now trying to face is who's going to control the orchestrator? Is it going to be you or an agent? And for that, we have a roadmap that is kind of interesting, but it's ever evolving because we're in that time. It's like Ilya said, we're back to the research of AI. So we're still doing a lot of research at the moment, and hopefully, if you find this interesting, we can collaborate and work together and doing some research and development. So, questions?
Let's thank the speaker for it. So in this model, right, I feel like the agents and like the actors are sort of monitoring the resources, and when the resources go down, the actors can then do cleanup actions, right? But what happens if the actors themselves fail, and like if they're running on like AWS or something like that?
So this is part of the architecture that we have to support that. We have a SaaS, and we have the edge components, which are the actors. This is where they scale. But eventually, the SaaS is the supervisors that we haven't talked about actually comes into play. So eventually, we have our own journal/database based on that event sourcing, and we are responsible on getting those up and running and doing the task again. So, yeah. By the way, I didn't know that you're doing a storage, so I thought opening with this question might be interesting, but you're probably going to answer it very quickly, right? Like, how do you find actors? But essentially, it's just good hashing. It's supposed to be very straightforward. But I have a lot of other questions that I created for myself. I didn't know if I would have 10 minutes, 5 minutes, an hour. It's my first time giving that presentation, so.
I've got a question, if you don't mind. You mentioned briefly about contrasting sort of this grain approach with like other systems like temporal. I'd love to hear sort of more about the comparison there about
Look at
like,
this.
yeah, like what you know, what is it something that that temporal can't do, or you think this is like a framework that you
So,
build on top of?
I would,
Yeah.
sometimes at night, I like to think about how I'm gonna take everything and gonna do it in temporal. Okay, I love them. And in my last startup that got acquired, we used them, which they were babies and now they're kind of amazing. But this is just the frameworks. We're talking about the product, and yes, it is replaceable. But when you look at the concept and the construct themselves, if you give them to enterprises, they would like something declarative, clean, small that they can interact. We haven't saw the product, but it comes with a lot of heavy lift. So yes, temporal essentially has its own, let's say, challenges from not fully distributed and how you're managing, but it's great to have underlying kind of solving a lot of long running processes and async distributed stuff. Definitely.
Question.
Yes.
Okay, so you mentioned like without a hierarchy, you have problems where some of the agents could like deadlock each other for resources. So you introduce a hierarchy, and I imagine like whoever is higher in the hierarchy will like organize access to the resources to prevent the deadlock. Is that a correct assumption?
So what we're doing here is we're trying to find the right. It's almost. Or I don't know if you talked about it with Lior, but back in the day, like maybe 10 years ago, we solved the traveling agent problem. I'm just kidding. Of course, you cannot do that, but we actually optimized the hell out of it. And we're doing kind of the same with the topology. We're trying to find the right dependencies and the right, let's say, route in order to eventually execute it. So we don't give one actor the responsibility of making it itself. We also rely on several rules and functional programming, not agents, to decide. So it's tricky because in some cases you're right, in some cases we just create execution topology.
Okay, and that's also how you like verify that these deadlocks can't happen. Like you have these rules, which are sort of guidelines.
So there is first I did my when I did my master focusing on contention sensitive algorithms and all the optimistic locking and all of those implementation. Essentially, you don't want to have locking at all. Okay, especially if you're using actors model accordingly, you should avoid it completely. But having said that, real world, you have databases, you have a lot of operation that you want to do, then yes, we eventually need we are running a lot of verification on those execution to try to understand if we're gonna heal the problem. And there's a lot of engineering in it also. So one of our principals is kind of the expert on how I'm avoiding lock. So yeah, I'm kind of giving that to him. So okay. How do you handle long-running agents that need to stream tokens? So it's kind of a weird question because it lacks context, but I know that you guys are working on data pipelines. And in data pipelines, there are many ways to go, but eventually you don't want to roll back or you don't want to kill something that is transmitting or streaming. So eventually it's from that world of long-running processes. And actually we make sure that TTL does not apply in such cases that we can kind of monitor traffic. So yeah. Okay. Any more questions? Yeah.
So when you introduced the Saga model, we talked about splitting up work into multiple sub-transactions and then having compensating transactions for rollback. Do you encounter like ordering problems between ordering compensation transactions across different, I guess, sagas, or
Yes.
how is that handled?
Yes, and this is where the real life again happens, because in many cases, even fallbacking orderly fashion might encounter conflicts, and we have many resilient mechanisms to kind of look at different problems and try to solve them. And if not, we're raising it to the user to decide what to do in these approaches or agents sometimes. But yeah, it's a problem. I do want to show you that. All right. We do have a roadmap that is interesting. And I put here stuff without knowing the audience, really. I didn't know that you guys are focusing on storage, for example, because we have more project around that area with large enterprises and how we can optimize model serving and hosting on, let's call it AI pods, for lack of a better term. So that is going to be very interesting to join and gonna help optimize that for enterprises. But we also have more items that we're exploring and researching around Glassbox, which is the behavior of agents within those environments, because this is not deterministic environments. There are a lot of frameworks right now that AWS is issuing and other cyber companies issuing, and we have a lot of context that we can provide to those systems other than just the action that the agent is doing, because we're based on intent. So all the product that you haven't saw is actually based on which project am I in, which developer, how many infrastructure are involved in that, what type of application. So all of that context can very be useful in what we call the Glassbox approach, which is monitoring for weird activities and behaviors. And we have more stuff that we can talk about.
One question.
Yes.
Okay. So what I was thinking about agentic systems, I would compare it with microservice architecture. Like you have independent service, different services talking to each other. There is a independent failure problem you need to deal with. I feel like they are very similar. I just cannot think of a new problem in agentic system that does not exist in microservice architecture. I just wonder whether you can identify any. How would this, or put in a different way, for a microservice, when you replace it with a language model or any model, how would the problem be different?
So it's mainly around the determinism that is lack in LLMs and agents still. It's kind of fall back to the real origin problem of alignment when you in AI, right? You say, I don't know if you know the term alignment, but yeah, you tell it to clean the room and it kills you because you're the problem. So we observe such behaviors, even though you have construct like constitution, like you cannot do this, but they will find a way. So the lack of determinism, this is probably what splits between functional and microservices or just software approach to whatever you're going to get. But again, I attached a paper from Meta around how to do agent collaborative frameworks better. And they talk about stuff like that and how it's similar or not to just programming. Well, it's really interesting.
Is that, but at the end of the day, is this problem more about how do you ensure your output align with your input? It's more like, how to validate your output. It's more like, I'm thinking about more like system-oriented problems, but I know some research on like validate the output of language models or providing assertions such that you can sort of know whether the output align with your input, that sort of thing, but that is more like per language model thing. But I'm thinking about for the whole distributed system-oriented perspective.
You're right. When we're researching this area, we look at agents from the granular approach to the mission-oriented approach of the company, so-called, or even kind of the government even. Because you have either like different hierarchies, and eventually you have to validate that the top mission and goal is actually correct. And it's gonna break down to a lot of, so again, it's a very interesting problem to talk about, but maybe next talk.
Thanks.
Yeah, we should chat about it offline. I'll introduce you to Action, and I think like there's lots of interesting problems, because I think I definitely agree with your statement earlier on that what you're building is basically the operating system for this environment. And like I think it also has a lot of like database principles in it, right? Transactions, rollback, so on. So I think there's a lot of stuff that really resonates for like systems people.
I think that every software company, and I don't know, this is recorded and I'm maybe talking my own kind of mind, but every company trying to find now a purpose, a real purpose now that agentic is here. And every time that I think about what we cannot replace still is databases. It's actually those concepts, those constructs, you have to store data, you have to access data. They cannot replace that. And so I'm a big fan. By the way, my Science, by the way, what we did is basically we took MonetDB, if you're familiar, and we made that enterprise grade. So I enjoy researching databases as well. So.
Tishin is our database professor, so we should definitely chat after the talk.
So
Sorry, Al.
Oh yeah. So when you have like millions of agents, right? So if something goes wrong, how do you go about debugging?
So we haven't talked about it, but one of the key principles of environments that we provide is what we call introspection. And introspection is actually the superset of data and state that we can collect, and we bring that to the user or to the agent to help troubleshoot. I have an excellent demo, by the way, of something that goes wrong, and you click on a button that provides you all the context for other agent to start the investigation. And without that, it's going to take a lot of time to understand the root cause. So in a nutshell, you have to find mechanism to get the right context in the right boundaries. And
Do you run into privacy and the legal problems and do something like that?
Yes. And this is where the cutoff of other tools out there that can help and basically introspect into the data. So this problem of privacy right now, on a higher level, we look at it as if you provision a setup, an environment for an enterprise, in many cases, they don't have problems with adversaries, right? So you can share maybe, I don't know, space or storage or compute, and it doesn't matter. And sometimes it does matter because you don't want data from staging dev to be part of production. So how do you create that isolation? And it falls back to the primitives of CPUs, GPUs, registers. How do you control that? What controls do you have? And how do you leverage them? Which I love because this is real life. And what we do in environments is we actually create that PaaS layer, that platform as a service layer, that knows how to control and operate that to allow for you to operate in isolation. Okay? So not all architectures support that, but in many cases, this is the challenge that we want to solve also. The isolation approach, so you won't run with neighbors.
But sometimes when you try to complete a very complicated task, right? They might involve multiple agents, so they're owned by different companies, for example, right? Okay. So I mean, if I were running a company, I would be very
scared. And
scared.
if Lior, our CEO, was here,
what you're doing to the other guys.
oh yeah, it's a I would call a trust strategy and verification approach. You have to always show and prove your work before you're installing something, and you understand the boundaries of what will happen. And in many cases, we cannot. And right now, the industry in that voodoo phase, limbo phase of how to create real true isolation and security when it comes to LLMs, AI, data, either transferring or even in the same kind of compute space. It's just another open problem right now that we're building upon. NVIDIA is building a lot of tools on it right now to do that, and Intel, etc.
So this kind of related problem is that, okay, if your business, okay, is about basically the big pushing, okay, then you can say, okay, we can always like try to recover your recovery action that you can perform to roll back, okay, the action that you've taken, right? But do we have customers, okay, that have businesses that involve changing physical states of objects.
Like, do you have any like robotics customized?
Yeah, if I'm in the factory, right, I mean, if I want to use the system, right? So,
So and again, I know this problem because, have you been in GTC lately? GTC, the conference of NVIDIA.
oh, no, I haven't.
So they are talking right now about these problems and how can we solve them? It's still not clear, at least not to me. Not that something that I'm aware of that we can use, but it's still
There's a serious legal problem, or things like that.
Yeah.
Anything you change the physical state of anything.
yeah. I don't know. Yeah.
All right, I think we should wrap up. Let's thank the speaker once again.
Wow, amazing. I can't believe that we survived this together. Okay.
Thanks a lot, David. Like, this has been great. Yeah.
Thank you.
Yeah. Right, yeah, no, I think we should just like, if we will disconnect from Zoom, I think we will stop.